Welcome to Fun with Science, Engineering, and Technology. My name is Mr. Ross, and this morning my helpers are Donna and Jonathan. And we thought we'd do a few little things different this morning. We're going to have a couple kinds of things. Right? Primarily, the first one is because yesterday was the first day of spring. Right? And then next month is April, which is National Kite Day. So what we thought we would do is we'd talk a little bit about spring, right? What causes spring, and what makes kites fly, right? And those are couple pretty important things because, first of all, they're favorite questions on the MCAS. You go to take the MCAS test, and whenever it is, the end of April, first part of May, right? There's probably going to be some questions on there about, the spring, right? And what makes kites fly, or what makes anything that's heavier than air fly. So we're going to do a little bit of a review. What's this thing?
Airplane?
It's we all recognize this as an airplane, right?
Yep.
And I know that you, in class, you just not too long ago went through all the forces on this airplane.
Yeah.
Yep.
You remember what they were?
Yeah.
Yeah.
Kinetic energy,
potential
energy.
Okay, we got kinetic energy and potential energy. But what about the force? Okay, those are different kinds of energy, and we need some energy to do the work to make this airplane fly, right? So in this particular case, the potential energy is stored as
an engine.
it's stored as fuel, right? That fuel, when we burn it, we take that. What we're really doing is we're taking that potential energy that's in the aircraft fuel, with the airplane fuel, and converting it into kinetic energy, which is potential energy is stored energy.
Yeah.
Kinetic energy is the energy that we're
Doing right now.
but we're using, right?
Yeah.
Or you can think of it as moving energy. So we have those, but we also had some forces on here, right? What happens to my airplane if I just let go of it?
It's
Make
gonna
it
fall.
fall.
It fell down, right?
Yeah.
What caused that?
Gravity.
Gravity. Okay. So we got one force. We got one force called gravity, which is trying to pull this airplane down, which is also trying to pull the big airplanes down. What's the others?
Thrust.
Thrust? What's thrust?
It's where you get enough speed to like go forward. Like you would have to accelerate, and then you higher pressure and lower pressure go on the wing, and then you lift and you fly.
So okay. Well, let's take them one at a time because you did two on me. You snuck an extra one in there. You snuck in. I was talking about thrust, and you snuck in lift. So let's talk thrust first. All right. In order for this, we got gravity pulling it down, right?
Mm-hmm.
We got thrust, which makes it move through the air,
Yeah.
right? It has to move. It has to move through the air. If I were to take this airplane and throw it a little bit, put some thrust to it, it would fly, right? So we have to cause it to move through the air, right, for it to fly, and that's what the thrust is. That's what the engine gives us, whether it's a propeller-driven airplane, right, or whether it's a jet airplane, right? It's a thrust, and it's the thing that makes the plane go in this direction. You said it. What was the other one you talked about?
Lift.
Lift. What's lift? Lift is the one that makes it go up, right?
Yeah.
So we got gravity trying to pull it down. We got lift pushing it up, and we got thrust making the airplane go in that direction. Is there another one? What's the other one? Drag, right? Drag is what's trying to hold it back, okay? And so what we have is we have some wind blowing. As this airplane moves through the air, the wind is coming along, striking in the airplane, right? And what it's going to do is to cause it some drag back here, right? Try to hold it back. It's like if you get running real fast, right, and the air hits you, right, what's it going to try to do? It's going to try to hold you back a little bit, okay, and that's drag. Okay. So, we got gravity, which is caused by the Earth. We got thrust, which is caused by the engine, moving it this way, and we know we have some drag. What causes the lift? What causes the other force to make it go up?
The
Air pressure.
Air pressure. What air pressure are you talking
The
about?
high air pressure and low air pressure.
High air pressure and low air pressure. Tell me about that.
Well, when it's going, the low air pressure goes on the top, and then the higher pressure goes on the bottom, and the high pressure pushes the plane up.
Okay, so what you're saying is this airplane goes through the air, right? I really got a wind coming across here, right, as it moves through the air. So there's air flowing underneath the wing, and there's air flowing over the top of the wing, right?
Yep.
And the one, and that's called Bernoulli effect, okay? The one going over the top of the wing, the air moves a little bit faster, right? And when you make the air move faster, you lower the pressure, right?
Yeah.
So what we have on the wing of my aircraft here is I have a high pressure on the bottom and low pressure on the top, which gives me the lift that forces it to go up. Right? So, let the airplane stand still. Do I have that lift?
No. Well,
Yeah.
yeah, because what was the question?
If the airplane's standing still, if it's sitting on the ground, right here, standing still, it's not moving. Do I have any lift on the airplane?
No.
You sure?
Well, the wheels, like, they're.
Well, the wheels are holding it up, yeah. The wheels are giving a little lift.
Well, I think air pressure's still going, but I don't think
Because
there's.
it's not
Well,
moving.
to get the lift, the Bernoulli effect, we have to have air going across the wing, right?
So you need speed?
So what we need to do is we need to get this airplane going, right, because of the thrust.
Mm-hmm.
It makes it move through the air, right? And that's what causes high pressure on the bottom of the wing, lower pressure on the top of the wing.
Yeah.
It gives us lift. What if it's sitting on the ground and not moving? Does it have any lift?
Nope.
Well, it has potential.
The
maybe.
engine's shut off, has no thrust, has no drag.
Nothing.
It's just sitting there, right?
Yeah.
No lift.
Nope.
What if it were sitting there, right, and I had a hurricane come along, and I have a lot of air flowing in this direction, a wind?
Mm-hmm.
What happens now?
You can lift.
I got lift, right? So really depends on how much air, how much wind we have, all right? The airplane, the engine could be stopped, but if the air's flowing across it, right, I could get some lift, and the airplane could actually rise up. Right. So we got all those things covered, and if we go back and we look at the airplane over there for a moment, if we look at our little chart here, we have a nice little picture of an airplane. We have thrust, which is given to me by what?
The engine?
The engine, right, and the propeller. Right? And really what is happening is the propeller, if we look at the propeller and it's turning, right, it's pushing air back in this direction, right, and which gives me another force, which is called this thrust force, pushing it forward, right, and the same thing happens with this jet engine. What's gravity doing?
Trying to pull it down.
Trying to pull it down towards the center of the earth. And because of the wind or the air moving over the wing, right, we have higher pressure on the bottom of the wing, lower pressure on the top of the wing, and it causes it to lift up. No. And that's going to give me lift, which counteracts the gravity, and then I have some drag, which is trying to slow the airplane down,
Yeah.
right, trying to pull it back. All right, question I always like to ask. Turn my airplane upside down. Now what happens?
It's gonna go down?
It's still the same basically, but I think the low air pressure still go on top, and then the high pressure still go on the bottom. I think. I don't know.
Well, but this portion is still, it's flat up here, and this is curved down on the bottom. It's flat on the top, curved on the bottom. All right, so if this is moving through the air this way, all right, the air on the bottom of the wing is going to be moving faster because of the Bernoulli effect, and I'm going to have low pressure on the bottom of the wing,
And
high pressure on top of the wing. So what's the airplane going to try to do?
Go down.
Go down. All right, but airplanes do fly upside down.
Some of them.
Some of them.
Yeah.
So how does that happen?
I don't know.
Okay, you don't know. All
I
right,
think-
I'll tell you. Okay, because there's another force. If we take the airplane, let's put it right side up again. We have the Bernoulli effect, which gives us some lift. Okay, but if the plane is like this and it's going through the air like this, right, so that the wings are up a little bit, the air is coming across and is striking the bottom of the wing and going down.
Mm-hmm.
Right? To get that air to move down, it's going to take a force. Right? And my good old buddy Sir Isaac Newton said forces come in pairs. Right? So as that air strikes the bottom of the wing, there's a force that pushes the air down. You got to have another force in the opposite direction, which is going to do what to the wing?
Lift it up.
Lift it up. So if we take a little and change the wing a little bit, right?
Hmm?
The air coming across hitting here is going to give me some lift. If I turn the airplane upside down and I fly it like this, right? So that it's moving through the air like this. I got the same thing. Air's coming across, hitting the bottom of the wing, going down, right? And I get some force pushing up. I get also the air as it comes over the top of the wing, right? We get some Bernoulli lift too because the air can't just follow this wing right straight down. The air is going to come over the top of the wing, go like this a little bit, and give me a low air pressure on top of the wing. Well, in this case, well, it's the top of the wing because my airplane's upside down, right? But, right, which is going to give me some lift. So airplanes can't fly upside down. All right. What'd I say? April is National Kite Month.
Yeah.
You going to go out and fly a kite?
Yeah.
How's the kite fly?
Basically the same way.
Basically the same way. Go back here and get my kite. Okay? You're right. If I take my kite and I look at it, all right, if I look at the kite like this, all right, it's shaped sort of like this thing here, right? So flat across the bottom here, and the wing, one edge of it goes up. And I have some thrust. I got the same four forces working on it. I have thrust, I have gravity trying to pull it down. If I let go of it, it's going to fall. I have some lift, if it's going to fly, and I have drag. Now then, this kite, it's just sort of a flat thing. It doesn't have any curved things to it. So now then, how's it going to fly? Take my kite and I put it out here like this. And where's the thrust come from?
The wind.
The wind. So if I just throw this kite up in the air,
No, you have to
Well,
run.
it's gonna float a little bit, but you have to
Like get a running
have a
start,
running start.
and then it's like
okay, let me ask another question. Yeah, you got to get it. What you're doing when you get a running start, you get some air pulling across. You got thrust. All right, how's the thrust getting to the kite?
how to thrust into the kite.
Yeah.
From
What
the
happens
bottom.
to the string breaks? What happens to your kite?
It's got
Well,
four.
it's gonna go.
It's
It might
gotta-
leave because it stays in the air.
Is it going to stay up there? If
No.
the string breaks, what's it going to do?
It's got four to the
It's
ground.
going to fall. You've flown kites before, right?
Yeah.
So if the string breaks, it's going to fall to the ground. If the engine quits on my airplane,
It's gonna fall.
it's going to fall, right? Why? Because
It's
It
not-
has no
it's
more
energy.
I have no more thrust.
Yeah.
Yeah.
Right? So the same thing is true here. Of course, my string that I have is really
Thrust.
causing the thrust. Okay, it's trying to hold the kite steady, right? And if the wind is blowing, which we need the wind to blow, right? So we're trying to hold it steady, and the wind's going to come along with my kite. And what happens then?
And it can lift.
Okay, how do I get the lift on this kite? I don't have any curved wing. How do I get the lift?
Well,
Try to.
How do I get the lift when I turn my airplane upside down?
the
Air pressure.
air pressure, but it turns because it doesn't go straight like on the wing.
Okay, what is happening here, right, is my kite's like this, okay, and then we're holding it, okay, with a string, giving it some thrust, right? The wind is coming along, hitting the kite, and going
Going down.
down, right? And what causes the wind to change direction is some force, right? Force pushing down. And that in turn, my buddy Sir Isaac said, forces come in pairs again, and I have to have another one which is going to push the kite up and give it the lift. So, that's the way I get my lift on this, right? What's gravity doing?
Trying to pull it down.
Trying to pull it down. So I still got gravity, I got lift, I have my thrust, right? And then as the air comes across the top of the kite, right, it causes some turbulence and so forth back here, and what it does is cause a little drag as trying to pull it back in the opposite direction. So, all right, what else do we know about this? This is pretty simple. It's, a couple sticks and a little piece of plastic, and it's able to fly. What's this thing for right here?
The tail.
That's the tail. What does it do?
Well, I think it helps.
What if I take the tail off? Will it fly?
No, I mean maybe, but not as well.
Not as, yeah.
Not as well? What do you mean by not as well?
But when it gets high, it will like kind of stay up pretty low.
All right. Well, we don't want my kite to do this, do we?
No.
All right. So what this tail does, right, is down here, the wind's blowing against it, and it produces a little bit of drag, right, which puts a force on the bottom part of my little diamond-shaped thing here, right, which causes the kite to stay upright like this. If you take the tail off, the chances are the kite's going to start spiraling. It may do that anyway, right, depending on how hard the wind is blowing, right, but it could start going like this, right, and once it goes like this, most likely it's going to go
Down.
down. Right. So, now, the other thing that's important about, you ever build a kite? I mean, not from a kit. I mean, not to go to, the store and buy one, right? But,
Well, yeah, I did in Boy Scouts.
oh, you built one on Boy Scouts? All right. So, the other thing that's important with a kite is where we have this string attached, right? And what's important about that is we want the kite to be about the way I'm holding it when it's up in the air, right? That's about the best, where we get the most lift. We don't want it like this, right? We don't want it like this, right? And the thing that controls the angle that I have here is what they call the bridle, right? It's just this string, right? And if you notice, this one is sort of got a little loop in it, and it's really sort of adjustable. We can move it up and down, right? If we move it up here, what we're going to do is we're going to cause the kite to fly like this, which reduces the lift to somewhat degree. All right, so we need to adjust this up and down to get so that we get some height out of our kite. Now, what else do we have? What else do you notice about this thing? Besides it's painted all kinds of weird colors, but what else about it?
Sticks.
Sticks, what about the sticks?
They go
The
like
sticks
across.
make it this figure.
The sticks are going, this one here, it's bowed a little bit, but it should be like straight, right? And these two here, what about them? They go across it, right? But what about it?
They like pointing a little bit up.
They're pointing a little bit up, right? So if I hold my kite like this, okay, you can see this tip and this tip is up a little bit. Wonder why they did that.
To get more pressure.
Get more pressure? Well, the reason they did that is sort of the same reason they put the tail on it, just to make it a little more stable. And this is called a dihedral, right? And you ever hear that word before?
No.
No.
Oof. Big word. Dihedral. Dihedral is an angle, right, of two planes. You know what a plane is? Not that airplane, but a plane.
Yeah.
Like, just like
Like a what?
a surface, like a.
Like a surface, like this surface here,
Yeah.
right? And right, like this surface, right? Like the surface of this
Table.
table.
Yeah.
All right, plane actually only has 2 dimensions, right? We can sort of represent it with my piece of paper here, but my piece of paper has some thickness to it. Planes don't, right? So this dihedral angle that we're talking about, right, just to show you what it is if I can hold all this, is this angle in here, right? Like it's shown on my chart. And we take these 2 planes, this one going this way and this one going this way, and this is the dihedral angle. And the reason they do that on the kite is to make it a little more stable, right? Because what happens, the kite can go this way, right?
Mm-hmm.
You can go back and forth, back and forth, back and forth. And as long as it's straight up like this and the wind is coming straight onto it, right, both of these surfaces look to the wind as being the same. So I got equal forces on both sides of the
Yeah. Kite.
kite.
Yeah.
That's what this thing is, the kite, right? Right. If it tries to turn this way, now what happens?
That's gotta stay. That's gotta turn too.
Well, this whole thing turns, all right? But if it's flying like this and this turns this way, right, what happens as far as the wind is concerned, it looks at this and it sees this as a bigger area, right? And this sort of is turned off to the side, and it really looks to the wind as like a smaller area, right? So where am I going to get the most force?
This side.
That
So what's the kite going to do?
It's gotta
turn.
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 Turn back until the 2 forces on either side are equal,
Yeah.
right? So if it goes this way, now what happens?
Gotta push
Well,
This side here is going to look like the wind
Bigger.
is the bigger.
Yeah.
The side over here is going to look
Smaller,
Smaller,
so
and
this
it's
got
gonna-
turn.
I'll turn this way. If this kite were perfectly flat, right, like this piece of paper, like you just picked up, right, they're perfectly flat, and I turn it, both sides of it, as far as the wind's concerned, looks the same, right? So it won't turn back, right? And if I turn it this way, both sides of it look the same, it's gonna turn back. And if you notice some of the airplanes, this particular one doesn't have it, but on some of the airplanes, the wings come up a little bit on both sides, right? For the same reason, for the stability. So as this airplane is coming down, right, and if it tries to go like this, right, this side is going to look bigger than this side, and it's going to force it back, right? So that gives me some stability. So even though my kite doesn't have that curved wing like the airplane, what kind of force does it have on it?
Kinetic?
Well, we got some kinetic energy, okay, which is the wind,
Yeah.
right? Makes the wind move. Forces now. That's energy. Force. Energy is the capability to do work, right? Whether it's potential or kinetic, right?
Okay.
Force is pushing you, all right? So, and of course, I have to have some energy to be able to push you a little bit, right? But they're sort of two different things. So what kind of forces do I have on this?
Thrust,
I have thrust,
lift,
lift,
gravity,
gravity,
drag.
and drag. Same thing as I have on my airplane. In fact, anything that's heavier than air that flies, right? Kites, whether it's a diamond-shaped kite like this, or an airplane, or a helicopter, or a rocket, or whatever, has those four forces on it. Okay? Which is, going back and looking at them again, thrust, drag, gravity, lift.
Lift, okay.
Okay. And this little angle here is called what? A dihedral,
Dihedral.
right? And it's on there for stability. Okay, let's put this down a minute. All right. The reason we're worried about, well, we're not worried about it, but the reason we're getting ready to go fly kites is because it's spring and the weather is
A little bit nicer.
going to get nicer,
Yeah.
and we're going to have a little bit of wind, and we can go fly our kites. Okay? Yesterday was the first day of spring. It was the spring equinox. Where was the Earth in relation to the sun yesterday?
It
Well,
was
probably today too, but
like halfway
halfway where?
around it already. Well, a little bit less than halfway.
We got the Earth.
Yeah.
Okay. We got your head is the sun. Okay.
Okay.
So show us where the Earth was.
It was like the Earth was like a little bit like here.
Well, that's a good place for it to be, yeah. But why does that make any? Why does that make? Give me get there. Why does that make any difference than if it was over here or over here?
Because
Or up here.
Because that sun will go to it.
Well, no, you're bright all the way around,
Yeah.
right? So you give me sunlight all the way around. So if I'm over here, I'm going to get the same amount of sunlight as if I'm over here, or I'm over here, or I'm over here, right? So what made yesterday so special?
How close the sun was to the Earth.
How close the sun was to the Earth? Do you know that the sun is closer to the Earth in the wintertime than it is in the summertime?
Yeah.
Cause like
You did this in the 7th grade, I think.
not really.
No, not you. You weren't here?
No, I was in New York.
Oh, you were in New York. Oh, you did it in the 7th grade then.
Yeah.
Okay, so why don't you supposed to know all the answers? You were in New York. I'm sorry, right? But that's okay. Let's talk for a minute. Okay, the Earth is going to revolve around the sun. Don't feel bad because there's a lot of grown-ups that don't know why yesterday was spring, the first day of spring either, right? You go ask them. The guys they do a survey every once in a while. They go down and ask the guys that just graduated from college this question. You know how many know the answer?
Oh.
Almost none of them. Right, so don't feel bad. Right. So we got the Earth here, right, and it's going around the sun, and it's going around the sun in a plane. Right? We take a plane,
Mhm.
right, and we put the sun in the middle of it, right, and the Earth goes around, and it goes around in that plane. And what makes the difference is, Earth's like, what's the Earth doing besides going around the sun?
It's twisting.
It's spinning, right? It's spinning. So it's like a big gyroscope, like a big top, right? So now in relationship to that plane, it's setting off at a 23.5-degree angle like this as it goes around. It's not sitting straight up like this. It's like this.
It's on axis.
Right. So since it's spinning, it's like a big top. So no matter where it goes, right, it's always off at that same angle. It's always pointing off that same spot out in outer space out there. So now then, what happens is if it's over here, like this, right, and it's tilted off in that direction, your bright shiny face is going to put the most sunlight where?
Right, like right here.
Down in here, down in the lower
Yeah.
hemisphere. So what time of the year is it going to be down here? It's going to be hotter down here below the equator.
Gonna be like
Hot
summer
up
there.
It's going to be summer here. What's going to be up here?
Winter.
Winter. How about that? What happens if it were setting like this?
It's gonna be like equal.
It's going to be like equal, and it's always going to be equal, right? We're always going to have springtime. Let's turn it back. Okay, let's put it set it up like it's because I like springtime. But because it's setting off at 23.5 degrees, right, and it's right out here, right, we got more your bright shiny face on the bottom of the Earth, down in the lower below the equator. So it's summertime down here in South America, and it's wintertime up here in North America. So now then, when it gets around over on this side, take it. I can't reach all the way over there. Right? It's going to point off where?
Right
23.5 degrees, right? Right? And it goes around. Just take it all the way around, right there. No, just hold it right there between you. Okay? You got it pointing in the wrong. You just jiggling the Earth all the way around. It's got to point. The pole's got to point up that way. Yeah, right, like this. Okay, now then, your bright shiny face is shining where?
Like right here.
Well, what about it down here too?
Yeah, a little bit right here. But.
Well, no, it's
So it's like,
equal, isn't it?
yeah, a little bit more.
It's like equal, right? So you got as much sunlight north of the equator as we have south of the equator, and that was what happened yesterday, right? And the daylights are both exactly the same, right? The amount of daylight we get. We take it around here behind you. Oh. All right. Now then, what is it?
Now it's fall. Like more up here.
Yeah. Okay. So it's more up above the equator. So it would be summertime, right?
And like winter.
And winter in the south of the equator. And I bring it around over here like this. Now then, what?
It's about equal.
About equal again. You know what that is? That's the
Fall.
fall equinox, right? We're getting ready to go into winter again. So we go around. Right. How long does it take to do this?
365 days.
365 days about, right? It's not exactly 365 days, but it's
About
like about, right? And that's why every 4 years we have
a leap year.
a leap year, because we got to adjust our clocks and our calendars and everything, because if we don't, we're going to be all messed up. We won't know when spring and summer and stuff are. All right, so what is it here in North America?
North America, that would probably like
Fall.
be like winter.
Winter. Over here is,
Pretty much even.
okay, pretty much even, which would
Spring.
be spring. Behind you,
That would be
Winter.
summer.
summer in North America,
And then winter.
winter in South America,
And spring.
and spring? We only got two
No, well,
springs.
fall.
Well, okay,
sorry.
I'll go with the two springs because I don't like winter, all right? Because the next thing that comes after spring, after fall is going to be
Winter.
winter, all right? But this is fall, right? And this is
Winter.
winter, right? Here. You've killed the earth at my airplane and the whole business. All right, those are two very popular kinds of questions that are going to be on the MCAS. Not exactly the same, obviously, all right, because they change them every year, but pretty much the same. They're going to ask you, you'll probably have a question, right, about the Earth and its position around the sun and what season it is, and you may have a question about what happened to all the little charts here. forces on heavier than air flying
Yeah.
objects, right? We gotta have, what are they?
Lift, thrust, drag, and gravity.
Lift, thrust, drag, and gravity. And unless we're flying upside down, all right, we need to turn it over like this, okay? So we have lift, which causes us to go up, gravity, which is
I'm gonna go down.
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 We have thrust
Fully forward.
and drag. Now you notice one thing, right? I said Sir Isaac Newton said what?
Come in pairs.
Forces come in pairs. So I have thrust this way, I have drag that way. Right? That's one pair. I did say I could only have one pair, but I can have, on the same body, I can have several pairs, right? And I have gravity pulling down, and I have lift
Pulling up.
pulling
Pull
up.
up.
So I have pairs of one pair of forces here, another pair of forces here.
Yeah.
So, now, what did we do today? We went through
How a plane flies and how the Earth
Kites
how a
fly.
plane
Changes.
flies, and we found out that the kite
flies pretty much the
flies
same.
just like the airplane, right? It's shaped a little bit different, it looks a little bit different, and the thrust on the airplane is caused by the motor, right?
Yeah.
And the thrust here is basically caused by the string,
Yeah.
right? And we have the same forces on the kite as we have on the airplane. We have lift, we have gravity, we have thrust, and we have drag, and this tail thing,
That causes drag.
that causes a little drag and keeps the kite from going
Down.
like this, right? And this angle is called a what?
Dinitrous. No.
No, it's not a dinosaur.
Dihedral.
Dihedral. So that's it for today. We know all about what caused the spring. We know what causes kites and airplanes to fly. And we're going to take a break, and everybody's going to go out and fly a kite.
Okay.
Yeah.
All right?